Okay, gravimetric analysis. So, gravimetry means to take an unknown concentration or unknown number of moles in a solution using precipitation process. Using precipitation process. I'll give you a small example here. Let's take that you have barium nitrate solution. You have a barium nitrate solution where you can measure volume. Yes, no problem. But you don't know its concentration. You don't know its molarity. Now what can we do? We can use the precipitation method or gravimetric analysis method to get know this unknown concentration of barium nitrate.
So what do we know, sir? So we know.
Yeah, here we don't know the concentration, but we know this. If we react barium nitrate with a sulfate, let's take H2SO4, let's take H2SO4, sulfuric acid. We know both concentration and volume here. It's a known solution. And if we react barium nitrate with sulfuric acid, if we react barium nitrate with sulfuric acid, what are the products? It's a double displacement reaction. It forms barium sulfate, the white precipitate, and
the
nitrate.
Hydrogen nitrate.
Yeah, hydrogen nitrate or nitric acid.
Nitric acid. Yeah.
Yes. Or UPAC name? Nitric 5, ne? Nitric 5, yeah. Because there is another acid called HNO2. In some syllabuses, we call nitrous and nitric. But in your syllabus, you don't use these general names, isn't it?
No,
you
we don't.
UPAC names, yeah. In industry, sometimes we don't use UPAC names. Use these general names: nitrous, nitric, sulfurous, sulfuric, cuprous, cupric, the all Latin way. But in Edexcel, Cambridge, and VCE, these syllabuses, now even in Sri Lankan national syllabus, general names are used. But in all these international syllabuses, mostly, other than US, we use only the UPAC name. So we don't say nitrous and nitric, we say nitric 3 and nitric 5. That's how we name. Okay. But it's better if we know both, because after we study, we go to a corporate world. In that corporate world, mostly they use the general names. Okay. So, however, so this forms barium sulfate. It's a white color precipitate. Barium sulfate is a white color precipitate. And what is the other special thing in barium sulfate? Now, normally, generally, many precipitates dissolve in acids. Many precipitates dissolve in acids. If now you know there is nitric acid in the medium, does barium sulfate dissolve in nitric acid?
Not too sure.
Sorry.
I'm not too sure, sorry.
Not sure. Okay. So I'll give you a small hint to think about that. These are not standard ways. Now, when we do questions, I'll teach you some shortcuts to
Yeah.
think. Now, this is another shortcut. How can we take whether a precipitate is dissolved in an acid or not? Normally, nitric acid can precipitate chloride. Nitric acid can dissolve chloride precipitates, bromide precipitates. They can be dissolved in nitric, but not sulfate precipitates. Why is that? There's a hint. This is actually not for analytical chemistry, but for inorganic chemistry. We can use this. It's like this. Now, normally, if you take, now let's take like this, lithium, beryllium, boron, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur. Okay, sulfur is here. Nitrogen is here. Sulfur is here. Nitrogen's maximum oxidation number is +5. Sulfur maximum oxidation number is +6. +5 and +6. The maximum oxidation numbers. So nitric's maximum oxidation number acid is HNO3. Sulfur's maximum oxidation number acid is H2SO4. If we think about the maximum oxidation number acid, always remember any acid forms from element to right side in the periodic table is more acidic and is more acidic. So it's like this. So a sulfate, now you know this is a bit different story. I mean, there's no in normal standard chemistry we don't do this, but it helps sometimes. So now barium sulfate precipitate is formed by a sulfate. That means it comes from a sulfuric. Sulfuric is a strong acid than nitric. So nitric can never dissolve a sulfate in it. So nitric can never dissolve a sulfate in it. Why is that? Because sulfate ion origins from a more strong acid than nitric acid. That is the reason. But a nitrate, now let's think normally there's a inorganic point. Nitrates are not precipitates. I'm just hypothetically think a nitrate is a precipitate. If nitrate is a precipitate, but if you add sulfuric acid, it dissolves. Why? Sulfuric is more acidic than nitrate. There's this inorganic point. When you go from left to right in a period, acidity increases. When you go from left to right in a period, acidity increases. Okay, that's something extra. Okay, so however, barium sulfate doesn't dissolve in nitric acid. Barium sulfate doesn't dissolve in nitric acid. That is what we should know. Okay, so barium sulfate precipitate is formed. Now, I'm just discussing what is gravimetry. Okay, so now barium sulfate, after the barium sulfate precipitate is formed, you can measure its mass. Now, here some barium sulfate, I'll take a different color. here, now when some barium sulfate precipitate is formed, you can filter the solution and separate the precipitate, the solid mass.
Yeah.
Yeah. After that, but we should assure that all the barium nitrate is reacted with sulfuric. So we add some, we don't know exactly the moles or anything, but we think we add excess sulfuric. So we can assure that all the barium nitrate is reacted. So we take the barium sulfate precipitate mass, we should dry it, we filter it, we then dry it, we should assure it is clean, and then after dried, after it reaches a constant mass, we measure it, we weigh it with the mass, and from a data book we can take the molar mass. When we know the mass and molar mass, we can take moles. Moles equals mass divided by molar. Like that, we can take barium sulfate moles. We can take barium sulfate moles. Now I didn't balance this reaction. We should remember any reaction after we write, we should balance. So here there should be 2. 1 barium, 2 nitrates, 1 sulfate. Okay, all are balanced now. Okay, so now go to the reaction. This is chemical calculation theory. Ratio system. 1 barium sulfate is formed by 1 barium nitrate.
Yep.
1 barium sulfate is formed by 1 barium nitrate. So if the ratio is 1:1, barium nitrate to barium sulfate, now we take that from the molecularity or stoichiometry. Barium nitrate to barium sulfate ratio is 1:1. That means to form that amount of barium sulfate, equal moles of barium nitrate should react.
Yep.
To form that amount of barium sulfate, equal moles of barium nitrate should react. Now we know the moles of barium nitrate. If you know the moles and volume, you can calculate concentration, because concentration equals moles divided by volume. Concentration equals moles divided by volume. That's a very simple way, But that is not how exactly you will get questions. But first, I just said the basic idea. Is that clear for some extent?
Yeah.
Okay.
It's clear. Yeah.
But this is not how we do analytical chemistry. Why? I mean, the gravimetry is this, yes, but a scientist never takes value from just one experiment. Never take values from just one experiment. The way of science is always we should do it more times, because repeatability is a very important thing in science, in analytical science. So now simply this is okay. This gives you the concentration of unknown barium nitrate. Okay, no problem. And this is the way. This is the basic. But when we do it as a practical, and when it comes to your exam as a big essay question, big structured essay question, you don't stop there. Normally we go to the questions in the graph way. That means you take the barium nitrate solution and you add different volumes of sulfuric acid. You add different volumes of sulfuric acid and you take different masses of precipitate and you draw a graph with the volume of sulfuric and versus the mass of precipitate versus the added volume of sulfuric. And you draw a graph and you go to the final answer. I'll tell you how to do it with exemplary questions. We don't write anything here because I think it's useless to write theory here. If you do a question, a very good question, which covers both theory and the knowledge, the analytical knowledge, I think that's the better way. Okay. Let us do you have any questions to ask?
No, makes sense. Yeah.
Okay. Then let's do a question. Okay. Can you take your writing book? Because
Yep.
we should write that question because I don't have these questions in tute form. We have to write these questions.
Yeah, I got my book.
Okay. Wait, I'll give you a question. I'll take the whiteboard, okay, because I want to go and write things. Just let's go to the textbook. Nothing new, just nothing new. Okay, no problem, no problem. But they didn't go that much to graph way, isn't it? They just go to the precipitation. But I am aiming to the questions. So in the questions, you will get questions like, I mean, for A levels, you mean get question mostly as a graph. So we will go to a graph question. Then we will do these questions also. But before that, I want to show you how the real questions come. Okay, I'll give you the first question. I'll type here. First question. Following are details of an experiment proceeded to take stoichiometric ratio between A and B. That means we don't know what I and B, they are reactants, and we know that they react and form a certain precipitate. So the following reaction is done. It's done to take this stoichiometric ratio. Okay. Then let's move. I'll draw the table for you. There should be a table. We'll do 6 experiments. One, 3, 4, 5, 6. 6 experiments are there. And A is with a certain concentration, B is with a certain concentration. Okay. Here it's a experiment number. Experiment number. Here 0.15 m, that means concentration. A volume. Volume means in cubic centimeters or just milliliters. Just milliliters. And let's take 0.25 m B. It's also about volume. No need to write volume there. Just okay, I'll write volume. No, just milliliters or cubic centimeters, the same. And here, the height of precipitate. Height of precipitate. You know me. Now, we can measure the mass, but it's a big procedure. You have to dry, you have to take the mass and weigh. But if we can just go with the height of the precipitate forms, it will be easy for us. It will be easy for us. Okay. So experiment number 1, 2, 3, 4, 5, 6. Volumes used. Let's take, normally we take in 1, we take all are constant. That means all volumes are 5. 5, 5, 5. In B, I'll change 1, 2, 3, 4, 5, 6. Height in centimeters. Height in centimeters. 0.1, 0.2, 0.25, 0.25, 0.25, 0.2. Okay.
Like, yeah.
Yes. Then let's draw a graph for this. If you draw a graph for this, y-axis is the height. Y-axis is the height. X-axis is the, now the volume of A is constant, so it is not varying. Volume of B is varying. So let's take a volume of B as x-axis. Volume of B. So first experiment, second, third,
Um, Hello. Can't hear you.
Okay, you can write down this now.
Yeah, I wrote it down.
Okay. Now, how can we take the answer? Now, in this question, what was their need? What is the question? They needed the stoichiometric ratio. They needed the stoichiometric ratio. So we can take it like this. You know, where does reaction totally finish? I mean, where does reaction uh, totally has done without excess according to the data? I mean, which experiment number? In which experiment number they reacted totally?
From experiment 3 onwards.
Actually, on 3. After
On
3,
3. Yeah.
it is excess of
Okay.
B.
Yeah.
Yeah. So 3 is the point where
Yeah.
it reacts exactly according to the stoichiometric ratio.
Yeah.
Okay. Then what can we know? Then if we know that at experiment 3 it is totally reacted, then we can take the reacted moles, exact reacted moles, and that molar ratio will give you the simplest integer molar ratio will give you the stoichiometric ratio. So what can we do? Take moles. Reacted A moles at experiment 3. We take experiment 3. Before that, they are not totally reacted because the precipitation form is not the maximum. After that, it is excess moles there. So this is the exact point where it is reacted exactly without any excess. Okay.
Yeah.
So, yeah. So, then next one. Now take moles. On A's concentration is 0.15. Now, normally capital M means molarity, it's in moles per cubic decimeter. So 0.15 moles per cubic decimeter, you know, moles equals concentration into volume. What is the volume of A reacted? 5 milliliters. Sorry. Yeah, 5. But you should substitute in cubic
Yeah.
decimeters, no?
Decimeters. Yeah. We don't
Yeah.
usually use cubic decimeters. We just use volume like as liters.
Yes.
Yeah.
Yeah, we can do that. But yeah, here it's okay. Because why? Why here it's okay? Because here it's just a ratio, no?
Yeah.
I mean, but if in a question, if you want the number of moles, then you
Yeah.
have to do 5/1000.
Mm.
You have to. But here no need. Why? Because
It's just
it's
a
a
ratio.
ratio. Yeah, because it's a ratio. But however, because it's the correct way, I'll put 1000. Okay.
Yeah.
And B, reacted moles at third experiment, 3 volume. Volume is
Yeah.
3 milliliters. Concentration 0.25 into volume is 3 divided by 1000. Now you can take the ratio. 1000 cancels off. You can cut 5 to 0.05. So here 0.15, here 0.15 to 0.15. That means 1 is to 1.
Yeah.
So in this unknown reaction, actually we don't know that reaction. In this unknown reaction, yeah, the ratio is 1 is to 1, A to B ratio. So we have taken the stoichiometry.
Yeah.
Let's do some more questions. Okay. Because now this is about taking stoichiometry, but there will be more different questions. I mean, they can ask different things using gravimetry.
Mm.
We will cover everything here. Then you will see that the questions in textbook and exam questions are somewhat easier.
Yeah.
Yeah. Okay. Let's do another question then. Do you have any question to ask from this one? Oh, is it?
No, it's all right. Yeah.
All right. Okay. Good. Next question. I'll question number 2. A2. This 2 means it should be a subscript, but in Zoom app I can't like Word app I can't write subscripts.
Yeah.
A2 SO4. The subscript after the bracket is simple. That means we don't know what is A. We don't know whether it is a first group, second group, or third group. It should not be second group, because if it is second group, we don't write A2, because 2 to 2 cancels out. So it can be first group or third group. So however, we don't know. We don't know. Okay, right down. A2SO4N reacts with barium hydroxide.
Is it aluminum or
No, it's something unknown. A,
unknown?
not
Okay,
A.
yeah.
Okay, A. Okay. Reacts with barium hydroxide.
And is N unknown as well? Or
N is unknown. Yes.
yeah.
Yeah. With barium hydroxide to form barium sulfate precipitate. Following details or following data are taken by an experiment proceeded to take their stoichiometric ratio. Height in centimeters and experiment number. Experiment numbers 1, 2, 3, 4, 5, 6, 7, 8. Heights, let's take like here they don't give you the height values actually. No need, actually we don't need values. And 6 and then same like this. Goes like this and then same. Okay. And I'll give some extra data also. Concentration of A2SO4 and concentration of barium hydroxide and A2SO4N. In all experiments, they used as 4 milliliters and constant. That means A2SO4N volume remains a constant in every and each experiment. It doesn't change. In every and each experiment, it doesn't change.
So 4, okay.
Yeah, 4. I don't plan to draw the table. That's why I'm just
Yeah.
giving you that. Yeah. And barium hydroxide is the varying one. Varying hydroxide volume is the varying one. It varies like this. I'll put it here. Barium hydroxide volume in milliliters varies at 2, 4, 6, 8, 10, 12, 14, 16, like that. Experiment number is 1, 2, 3, 4. Okay. Okay. You can take all this down.
What's the values on the bottom? 2, 4, 6, 8, 10.
They are volumes of
Yeah,
barium hydroxide added.
at that point.
Yes. Yeah, on that experiment number.
So we're trying to find the concentration.
Yeah. Wait, I'll give you the questions.
Yeah.
Question number 1. Balance the reaction using N. Balance the reaction using N. Question number 2. Just keep 2, 3 rules and question number 2. Calculate stoichiometry. You should keep like 7, 8 rules for that. Question number 3. Calculate n, simple n. That's n to calculate simple n. This is the question. So I'll give you like 1-2 minutes to check it. Then I'll help you.
I'm just wondering how to balance with the n.
Yes, sure. I'll help you with balancing.
Yeah.
Okay. Here. A2SO4N. A2SO4N plus barium hydroxide, Ba, yeah, barium hydroxide. Normally, what are the products? Barium sulfate is one product, BaSO, plus A will go with OH, AOH, AOH. If they are sodium, sodium hydroxide like that.
What about the n for that one?
Yeah, now we are going to do that. Now in the left, there is n number of sulfur. So in the
Yeah.
right side also, there should be n number of sulfur. So we put n here. That's the first step. That's first. Then in the left, one barium, but sorry, in the right, n barium. So in left also, there should be n barium. You had to put n here also. Then, what is the other thing? On left, there are two A's. So on right also, there should be two A's. You had to put 2 here. But on left, OH, if you take OH group, 2n amount of OH group. So you had to put n here. Now I think it's balanced.
Two. Okay. Yeah. Can you do the stoichiometry again? So
Yeah, sure.
Yes.
So the point there is the maximum height is taken where the reaction is fully done. The maximum height means where, I mean, the place where maximum height is taken for the very first time with the least volumes. The point where maximum height is taken from the least volumes is the place where reaction has done totally. Reaction has done totally without any excess. Without any excess. Okay. So, because now a student can say after that, even after that, the maximum height is there. Yes. But now, barium hydroxide is in excess. Now all the barium hydroxide after experiment 6, even though the maximum height is the same, that means maximum height is the same means both are totally reacted. But now barium hydroxide is in excess. So if you do calculation with 7 or 8 or any other reaction after that, you will get the number of barium hydroxide in excess. It is not the totally reacted number of moles. It is in excess. So you have to take the place where it gives the maximum amount of precipitate. If they give mass, it doesn't matter now. We are doing with height. But if they give mass, same, no?
Yeah.
Yeah. Okay. So what you do is you take this, that means which one? Sixth experiment. This is the place. So then how can we take the stoichiometry ratio? Now in sixth experiment, we are sure they are totally reacted. Without excess, they are totally reacted. Fully finished. No excess of A2SO4 or barium hydroxide. That's the point where it is exactly reacted according to the stoichiometric ratio. So now take the moles. A2SO4, reacted moles. Reacted moles. Concentration into volume. Concentration is 0.2. Volume is, I think I said take all the volumes as 4, isn't it?
Yeah.
4. 1000 is not needed, but I just write this. Correct. Barium hydroxide at that position, you have added 1, 2, 3, 4, 12. 12, no? 0.1 into 12 over. Take the simplest ratio. Take the simplest ratio. 1000 to 1000 cancels off. 4 to
Why is it
12.
12?
Here. They say in the sixth experiment, they added 12 milliliters of barium hydroxide.
So should the 4 be 6 as well? 0.2 times 4?
This one?
Yeah.
It's correct because in all the experiments, we wrote in the question, I said that we take, added A2SO4 volume is 4 milliliters for all. It doesn't change. We only change added barium hydroxide volume. Okay?
Yeah.
Good. Now take the simplest ratio. That's it. 1000 cancels off. 4 to 12, 1 is to 3, no? 4 to 12.
Yeah.
0.2 here is to 0.1, 0.3. 0.3. 2 is to 3. 2 is to 3. 2 is to 3. That means 2 comes here, 3 should be here. That means n equals 3. Both second and third questions are answered.
So you know that ratio is that?
Yes.
So 0.2 is the moles per.
Yes.
Yeah.
Moles reacted from A to SO4.
Times by, okay, 4, which is the milliliters, and then
yes,
over 1,000 to liter, and then ratio is 0.1. Okay. What?
Is it
okay.
Yeah.
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 So we know that A2SO4 is 4 mil, right?
Yes.
It
should be given in the question. Yeah.
Yeah.
It should be given.
And then barium, yeah. So that one is at totally at without excess, that's 12.
Yes, that's the point where there is no excess.
Okay.
Yes. Yeah. So both second and third questions are answered.
Yeah.
This is the maximum amount you should know, not only for VCE, for Edexcel, Cambridge, Sri Lankan or your Victorian, for any A levels. This is the maximum amount you should know.
Yeah.
Actually, you will see mostly like 80% questions, they just give you to take moles, and I mean, they may not give, if it is a essay or structured essay question, they will give a big question like this, but otherwise, mostly I have seen questions like just take one experiment, take the maximum mass point and the ratio or the unknown concentration.
Yeah.
That's very easy, but this one is the best.
Okay.
There is another way where we change both volumes. Now here we keep one a constant and we only change the other one. There is another way where we change the volume of both, but I think doing it is not needed for you for A levels, because they never give questions like this. But I'll do 1 or 2 questions later with you. Questions like that. I think for now, gravimetry, I can give you more questions to do at home. I mean, to understand the theory part, I think this is enough.
Okay. Yeah.
Okay. I'll give you more advanced questions later.
Yeah.
We will do more.